So hope you can see my presentation.
Yes, we can
Right
see.
now, first screen slide. Can you see it?
Yes, we can see it. Make it full screen and you are good to go.
Oh, okay. Can you hear me?
Yes, yes.
It will, yeah, it will enlarge right now. So thank you very much, Honorable Chair, for this great opportunity to participate in your conference. Congratulations to all participants, and hope, as already Chair said that the conferences are organized for the duty to get some knowledges and to get some new ideas and proceed further with the researches. So thank you very much once again. And so I would like to present telemetry data for improvement for the crop production. And this presentation is prepared by me, Antanas, Juostas, and Professor Vytautas. First of all, everybody already knows that in Europe or in the worldwide, so we are really suffering of the green gas emission influence to our environment. So, and the European Union has called already some actions to promote this climate change mitigation. And it is already set for the European communities and probably in the worldwide as well. So there's some proposals how to do that. The environment would be more safer, that the food would be more safer. And actually it is a requirement already that emissions up to 2030 has to be reduced by the 55% compared to the 1990s. So actually it seems that it's very huge amount of the reduction, but compared to the 1990s, so all countries has done already some movements in the area of mitigation of the climate change. And actually the agricultural equipment, also the agricultural factories also strive to, or the move to the technologies which are saving the climate. I mean, by using the different sensors, technologies which are helping to pollute less, to control the mechanisms and the agricultural equipment that is serving for the customers to do the previous work as best as possible, as precise as possible. And actually, one of the issues, what I wanted to show you today, that it is telemetry systems what are installed already on the newest machinery, mobile machinery like combine harvesters, tractors, forage harvesters. So the telemetry means that by the television or the VR screen, you can manage, monitor, or monitor parameters. So it's not necessary anymore to sit down in a combine harvester then look on the parameters, how it works, how it performs. Now the customer is capable to do everything right from his office. And so via mobile network internet, he could get as much as possible the information, and actually depending on the different suppliers, I mean the different manufacturer companies, it is possible to read and to use more than 200 different parameters, and it's automatically recorded, automatically is saved, and automatically you can upload all the data about the machinery you are using in the field. And so that this telemetry system, by using the system, you can recognize the functionality of the machinery. Did it perform perfectly or not? So actually right now, how the customers are working, they are just telling that, okay, so this year was better Last year was worse. And what was worse? What was better? It's already, so I would say it is lost. It's only the idea, or it's a feeling how it has been happening, but not nothing exactly. With the telemetry system, you could say exactly what was worst part during the season. And during this research, we took the same model of the combine harvesters with 586, 85 the horsepower with a 10.5 meter cutter bar length or width. And so these three combines has been worked whole year in a different crops of the year 2020. Each time when the combine harvester has been running on a field, all the data has been monitored, and all the data has been recorded and saved into the clouds. And actually, the information you could get, it's only the like example, so that from this telemetry, you can take out the information, what you can see right now on the screen. So starting from the crop yield, the area harvested, and the fuel consumption, average yield per hectare, and so much and so much. That's plenty of the information. And it's not only that the machine or one or another did something, it's also separated by the crop you have been harvesting. As you see, it's for how much combine harvester has spent for the wheat, spring barley, rapeseed, etc., etc. So it's very, very precise and very exact information what you can do. You can read it right now. And actually, there's also the performance analysis. It can be done when you can see that there is a column with the different windows, and it's colored differently. And if I would take this almost last column, you can also see that customer could also take a chance to understand how the combine harvester has been performed. The color, yellow color in the columns, shows that the combine harvester been on a process, and how much in a process time it shows also in a percentage. If I would put the bar on whatever column on a live situation, it would show me exactly how much hour and how much in a percent the combine harvester has been spent. And this is a perfect. So we can see that it's almost 60, 70% of the process, but the rest, 30, 40%, it is spent for different other consumers, like turning around in the field, going from a field to another field, stopping due to the failure on a combine, stopping because of the customer is not capable to unload the grain during the driving. And those are the portions of the time are really, I would say that they could be reduced. And out of this picture, right now, I could say what can be reduced, and it can be suggested to the customer. So as I mentioned before, the 3 combine harvesters has been taken for the year, for the whole year. And this is a data that almost from 350 to 620 hectares has been harvested during the year 2020, different crops. And so there's, sorry, it's for the wheat only. And so we took only the wheat, how it looks like. And so the harvesting capacity, so it has been recalculated, and the liters per hectare. And you can see that the same combine harvester with the same functionalities, but with the different behavior of the operator, could make an influence. And this data could be also transferred to the other users, how adjust the machine and how to behave in the different areas and in different situations. And so the distribution of the combine harvester, so it's perfectly shown over there, and you can say that travel time portion 6%, turnaround portion is 6%, unloading portion while idling, just stopping the machine and loading out the grain. So it seems that the 30% of the total time is used, or is used not for the processing. And it's very, very great figure yet. Usually in Lithuania, in our country, so the combine harvesters are used 50 to 50. I mean the 50% of the process for the processing and 50% for the non-process part. It means it's quite a huge amount of the working time, and this is a question how we can reduce it, how to make it more profitable and more, I would say, crop and the fuel saving and time saving the process. And this is the result. So that's what we can also obviously see, where the machines been running on a field during the grain unloading. This green line shows that the machine was grain unloading during its run. And this shows that the grain was unloaded during its stopped machine when it was stopped. And this is a figure what I wanted also to show the graphs. The three first ones, EG1 to EG3, it was a combine harvester used with the automatic steering on, and EG4 and the EG6 with the automatic steering off, or actually it was manually steered. And also there you can see also the figures where depending on different operators, the figures are really, I would say, varying very much. And the amount of the process, 55, 56, 7%, are quite good, but those ones, 13%, 8%, 9%, and 4% are the time used for non-processing time. And the last one, brown one or red, so when the engine totally during the process time was switched off. So, and this makes for us very good overview, what to suggest and what to adjust, advise to the customer. And that one picture, what I wanted to show as well, that if you would sum those two columns, blue and yellow, you will get total amount of the grain price, what has been used for the last years. I mean, for the wheat, so the grain price was 273. For the spring barley, 227. And this yellow portion is how much of the grain yield or the grain price we are just using for the processing, and how much grain price are used for the non-grain processing, for non-efficient time. And actually, the time consuming from the time overview purpose. So it's one story, but when you are starting to show the customers the price of the euros, they are starting to count it. And actually, during this time, so it has been calculated that additionally, if the customers would run the machine with automatic steering, what is really useful, and unloading the grain, they could harvest from 31 to 74 hectares per season. And it could save from 10, almost from 9 to 17 hours per season, only on a wheat. And actually it is a huge amount. So you can imagine that combine harvesters could finish the work 1 or 2 days earlier. And it takes really a good assumption that if you are late with the harvest, your crop quality could be also reduced, and the price for the quality could be also not as such good as you could get before. So this is a main I would say the findings right now, but This research we are going to do and prolong in determination of the soil compaction and the fuel and the exhaust gas emission recalculation in each separate field, and it's possible to do it. So thank you very much for yours once again invitation, and if any questions, I am waiting for this.